Welcome everyone to another presentation up to the time. Today we are going to be looking at stairs. In particular, we're going to be focusing on stair details.
Right.
What does the term stairs mean? Stairs are a structure designed to bridge a large vertical distance between lower and higher levels by dividing it into smaller vertical distances. This is achieved as a diagonal series of horizontal platforms called steps, which enable passage to the other level by stepping from one to another in turn. So now we have just defined what the term stairs mean. Let's take a look at discussing the three types of stairs that we have here with us. Okay. Types of stairs. So there are three main types of stairs. These are straight stairs, turning stairs, and continuous stairs. So reading from left to right, let us clearly define and discuss what a straight stairs would look like. So this is the straight stairs over here. And it's fairly obvious why we call this a straight stairs. You can see straight stairs are stairs without any changes in direction. They are certainly one of the most common types of stairs found in both residential and commercial properties. So this is what we mean by straight stairs. It just goes in one direction. It doesn't change all the way. Not a problem there. Now let's move on to the second category of stairs, turning stairs. Turning stairs are the stairs which turn into other direction with landing or without landing. There are three types of turning stairs: quarter turning stairs, half turning stairs, and three-quarter turning stairs. So this is what we mean by the turn. The direction is straight here, and then at this moment it turns, and then it continues to ascend. So this is where the turn will take place, here and here. Okay, let's move on to continuous stairs. Continuous stairs are those which do neither have any landing nor any intermediate newel posts. They are therefore geometrical in shape. Continuous stairs may be of the following type: circular stairs, spiral stairs, and curved stairs. So one thing we realize here is that this is where it got its name from. Continuous curve, which are in the stairs, as we can see here. So these are the three main types of stairs that we would see in our world. After this, let's move on now. Remember just now I mentioned that turning stairs have three types. There's a quarter turning stairs, there's a half turning stairs, and three-quarter turn stairs. So let's have a look at these three types now, which all come under the general type of turning stairs. Let's look at these. So here they are. So what is a quarter turn stairs? A quarter turn staircase consists of two straight rows of stairs and a 1/4 turn of 90 degrees. With this type of staircase, from the base to the top, the steps and the person on them turn 90 degrees. So this is what we mean here exactly. This will be seen as a straight flight. And then at this moment is when the 90 degree would change. So the angle in here is 90 degree, okay? Which is also right here. That is a 90 degree angle. And that Oh, so it's here. So that's the quarter turn stairs. Let's move on now to the half turn stairs. Half turn stairs. It consists of two straight flights with two 90-degree turns. With this type of staircase, from the base to the top, the steps and the person on them turn 180 degrees. This type of staircase creates a space advantage to the base where the angles is incorporated, optimized space that otherwise be lost. So this is what we mean here by 180 degrees turn, right? 1, 8, 0. Right here. So one would ascend, turn complete 180 to continue. So let's move on. 3/4 turn stairs. A 3/4 turn stairs has its direction changed 3 times, with its upper flight crossing the bottom one. So 3/4 turn stairs. A 3/4 turn stairs has its direction changed 3 times, and its upper flight crossing the bottom one. It may be either be neo type or open neo type. Such type of stairs is used when the length of the stairs is limited and when the vertical distance between the two floors is quite large. So this is what we mean by the direction changes 3 times. This is the first change of direction here. And then this is the second change of direction here. And then this will be the third change of direction here. And at each change of direction, it goes through a 90 degrees. So there we have it. These are the 3 types of turning stairs. Again, we have the quarter, the half, and the 3/4 turn stairs. So let's move on to another category. Now we have over here the continuous stairs. So let's start with the circular stairs. A round staircase typically refers to a stair that is circular or curved. A circular staircase rotates in a round fashion around the circumference of a room, usually turns more than 90 degrees. A curved staircase does a sweeping turn in a smaller area that a circular stair and usually does not make. So this is the curve here. When we look at it on plan, and this is what it would look like in a perspective. Right? If you start here and you ascend. Now let us go over to the spiral stairs. A spiral staircase is a structure that is built around a central post that acts as an axis for its steps. So this is the central post here. In here. And it acts as an axis, meaning that all the steps are connected to this post. And it goes in a circular formation. So you send in this direction. Then you'll find yourself there at the top. All right. I think we can clear. And let's move on to the last stairs now. A helical staircase takes its name from its similarity to a helix. Typically flows in a circular path and revolves around a central axis that is empty or is occupied by other non-structural elements of the staircase. This is the main difference from a spiral staircase. So the spiral staircase has this in the middle as a main support. However, in this helical stairs, you don't get any main support in the middle. That's why I place that stair. There's no main. But the path is similar, whereas you have to take a circular path to ascend or descend the stairs, right? Which is similar here. So those are the two main differences when we look at these two types of stairs that you can observe quickly. Now let us move on. So now we're going to move on now to something called parts of the stairs. I wouldn't spend too much time on this because it's all right here. I'll just go through this quickly and point out these parts. Now this is a baluster, which is an upright support, often a vertical molded shaft. And you would find that here. So these would be balusters, right? And then there's the handrail. The handrail is a rail that is designed to be grasped by the hand so as to provide safety or support. This is where the handrail would be. So when ascending or descending the stairs, you would consult that rail for support, and that's basically it. Let's move on. The newel post. A lot of people didn't know what this was called. They just call it a vertical support or column at the bottom of the stairs, but it's actually called a newel post. Also find this at the top too, right here. Now, what is the soffit? Soffit, the visible sloping on the surface between stairs string, which is here. Slanted piece is called the soffit. Okay. And what is the base? Base slab refers to a slab of the stair that is slanted from the floor slab to the landing. Now, this in here would be called the base. So the base and the soffit go together. This slab in here is considered the waist. Okay. Now, what is the nosing? Edge of a step or stair tread that projects beyond the riser. So this is where the nosing would be here. This little point, it would be considered the nosing. Okay. Let's move on. What's the scotia? A molding provided under the nosing to provide strength to the nosing. Okay, so we just describe or we just identify where the nosing is, which is around here. This is the nosing right there. So if that is the nosing, the scotia, it is support under here, which supports the nosing. That's all you need to remember. Step. This is the portion of the stair which permits ascending or descending. A stair is composed of a set of steps. So this is where the step would be here. Let's put an ST here. So that would be the step. Now all of these that I'm touching would be steps. They also go by a different name. They also go by the name riser or going. Right? Right. So now let's go to where the riser is. A stair refers, okay, sorry, let me read it again. Riser. A stair riser is the vertical space between one step and another. So this is where the riser would be here. That space in there is known as the riser. All right. And usually that space is about 196 millimeters or 7 3/4 inches. Let's clear that. And what's the tread? A stair tread is the horizontal part of the step that a person will stand on. So here's this joint, these would be the treads here. You place your foot onto the treads. This would be the tread. Be the tread there. And the sizes of these treads can be 11 inches, or that would be 279 millimeters. So I've given you both the sizes of the tread and the riser. Now the tread is the same thing as the tread, so I would not bother to go into that. The going, what is the going? The going of a flight of stairs is the horizontal distance between the face of the first and last riser. Okay, so we have here in here, which is the going. So you can also see that the going and the tread pretty much the same thing. Because we have here the going, and then we also have down here the tread, right? So just learn these terms and please don't let them confuse you. Let's move on. So we move on to another sheet with more terms. We have the pitch. What is the pitch? Pitch, it is the angle which the line of nosing of the stair makes with the horizontal. Okay, so let us look at that. So this is the line of the nosing here, right here. And that line all the way down there, when that connects to back here, that will be called the pitch. All right. Now, some of these are very hard to understand first presentations because a lot of terms seem to be overlapping. That is the truth. Pitch, the string, the base, line and nosing, all of them actually are pinpointing, how to put it this way, they're pinpointing the same area, but they're describing things slightly different. That's the best way I can explain it without confusing anyone. Okay? So if you see that I'm pointing at the pitch, and while I point at the pitch, I'm also pointing at the string, and while pointing at the string, it's also relating to the base. Yeah, they're all many terms, but they're all pointing at the same part. Let's move on. Headroom. It is the minimal clear vertical distance between the tread and ceiling. So here we got the headroom distance is 6'8", which is 6'8" in terms of feet and inches. And that also relates to converts to 2032 millimeters. And this is where we talk about headroom. Here's a diagram which can express what that means. So this is where a person's head would be, the body, and then you stand there. So you're making sure your head does not hit right there with the ceiling or the roof of the next room. All right. String. Again, these are the sloping members which support the step in a stair. So this is the string here. Flight. This is an unbroken series of steps between landing. So this would be a flight. That would be flight, and that would be another flight of stairs there. right? Landing. Let's get to landing. It is the level platform at the top or bottom of a flight between the floors. So let's just see where the landing would be. This would be a landing here between this floor. Down here would be a landing. And then again, somewhere up here would be a landing. Okay. Line of nosing. This is an imaginary line touching of each tray and is parallel to the slope of the tray. Okay, so this is the line of nosing here. Imaginary line touching each tray and is parallel to the slope. So now that I've explained these terms, let us move on and see. Let's look at materials in stairs now. Now, stairs can be created or built with various materials. There's timber, there's steel, there's concrete, there's glass, and lastly, there are even some stairs that are made out of plastic. We will get to that. Let's have a look at these various materials as they're used to construct the stairs. So here we have a steel stairs. Yeah, everything here is out of steel. Going on, we have over here concrete, and this is concrete, pure concrete. And then lastly, under we have timber, which is right here and here. Everything is made out of timber, everything is made out of concrete in this one, and everything is made out of steel in that one. Now let us move on. Here we have the glass, and you can look closely and see the glass details, how the glass is connected to the steel. So this will be considered a glass and steel stairs, but for the most part, this will be described as a glass stairs. Yeah. This now over here is an unusual material used in the creation of stairs. This is plastic. This is plastic. Better believe that. So this will be plastic on glass. So these are the materials used in stairs. Now, that brings us to the end of our presentation on stairs. Now I need to get into what are we going to be doing today. Today, we are going to be looking at a previous CXC question. Actually, there are two CXC questions that I have here. And we are going to be looking at them, and both of them actually relate to joint stair details. So without any further ado, let's have a read of the first one. This is taken from the 2014 Building Joint CXC paper, and this is a section 2 question. Section 2 is the sketching design or 3D modeling design drawing. So the question asks us to make neat, well-proportioned three-dimensional sketches to show the difference between a reinforced concrete stairs and a timber straight flight stairs. Label the differences clearly. All right, now I can see this a lot better. Two stairs in a three-dimensional form. But before we do that, I'm going to draw these in orthographic formation first, and then I'm going to draw them in the three-dimensional form. That's one question there. What's the second question that we are going to be doing? The second question is going to spin off the first question. The second question asks us to make a neat, well-proportioned orthographic sketch to show clearly the following parts of a timber straight flight stairs. Now, first, before we do the isometric projection. So without any further ado, let's get into it. And I'm going to create my baseline. Yeah. And before we start, I think I need to let you all know what are the sizes that we are going to be using. Now I remembered I had my sizes here, but I would just highlight them again and look at the sizes I'm going to be using. The eraser is going to be 196 millimeter, and my thread is going to be 279 millimeter. So again, we know what the riser is. The riser is the vertical, and the thread is the horizontal. So let's use these two numbers. The alpha line, and I'm going up 196, then going across 279. So this is my step there. And I'm going to copy, CO for copy, and I'm going to snap here. And I'm going to copy this about 1, 2, 3, 4, 5, 6, 6 times. I think that's good enough because at the end of the day, this is just supposed to be a sketch. I'm going to connect a line from here down to here. Good. Now, I'm going to now create what is called the string, right? Or the pitch line. I'm now going to offset this a distance of 150. Offset 15, not fillet this. All right. So I think I got in my setup there for my steps or for my stairs. And now I need to change this into a concrete stair. So let's shut this off. Let's say that this shuts off here, right? And this is the slab. Okay. So straight away we have there a set of steps or a stairs. Now we need to make this concrete. I'm going to change this into outline so it's thicker. And how am I going to differentiate that this is concrete and not timber? Well, I'm going to insert my concrete material. Or bring out this, explode it in a random hatching here. Yeah, it doesn't matter. Then I'm going to max drop this. That's my concrete stairs there. That's done. What I need to do is I need to label this because I've drawn it and I need to label it. So I'm going to get a title bar, place that there, explode the title bar so I can edit it. And this is called concrete. Concrete stairs. I'm just trying to get this lined up properly, right? Now I'm going to scale down this whole thing because I don't want it too large. I think that's a good size there for me and for this drawing. You scale, not to scale. To scale because it's a sketch. Lastly, I need to label. Need the dimension. So I'm going to come over to my dimension layer and I'm going to dimension. Okay, these dimension lines are much better. I'm going to use these. So what I'm going to do is I am going to dimension everything in this particular style, and then I'm going to match drop, and it should take on this style of the smaller things. All right, so that's it. So now we can see what the thread is and what the going, or the thread and the going and the riser. Let's now label these. Now, let's go now and grab a leader. We grab a leader. We will call this the, let's call it first thing concrete. No, it's already labeled. Let's call this reinforced concrete. Put the arrow on the inside. Perfect. Place it there. Let's call that the rise slash riser. All right. I think we're gonna have to get a new arrow for this. Call that the thread. Thread slash going. Right? And that's it there. This isn't finished. This is just me creating an orthographic projection first before I create the isometric. So I'm just letting everyone know that. So that's the concrete flight of stairs, and now I have to create the timber. All right. So what else do I need in creating this concrete stairs? Nothing else I can think of. So now what I'm going to do, which is going to make it easier, I'm going to copy this, bring it out here, and then we're going to remove that, right? You realize now, let's just remove the dimensions, then we can always paste them. Now, in creating this timber stairs, we know that we need to have some members on top here. Let's offset, let's take that to 50. That is a member there. See, those are the members there. And also, some of these members are backed up around here as well. So let's put another 50 here. No, I'll leave it like that. So this becomes a solid piece of timber. Let's hatch in here so that we know. Let's see if we can find a timber hatch anywhere here. So that we just represent this as wood. I always have problems finding hatch that I'm looking for in this menu. Just do that. Okay, good. So this also will become a piece of timber. And what I'm going to do is I'm going to change the hatch on this, or at least change the angle. Yeah. So both this and this are timber members, right? So for this particular one, the razor is going to be an open razor, meaning that air can pass through the razor, and you will click your foot onto the thread and thread and thread, and then you wipe the razor. The razor would be open, so it wouldn't be sealed. As in concrete stairs, everything is sealed off. Okay, I'm looking to see what else I need to place here before I go and start drawing. And one thing that I remember is that a concrete has a joist. See how this goes now. Probably wondering what I'm doing. I'm just drawing a support member that is going to be in the background. Most people aren't going to see that member, so I'm just going to place it there. Now the joist is going to appear right here. There's joist. Right. Mm-hmm. Offset. That is 203 down. Let's see how that goes. Okay, do this. And then I'm going to place an X through this. This is also a piece of timber. At this stage, I'm not going to hatch it this way. I'm not going to do that. To differentiate, I'm going to place an X through that piece of timber. And what comes above this is the floor. So, 25. Thinking of using 25 rather than 50. Yeah. And I'm spacing out these members at 125 intervals. Okay. Now, what I'm going to do is I'm going to change this thickness of 50. I'm going to put them at 25. All right. So I'm just going to bring this down. Okay, change the direction so that people looking at it will be able to differentiate the different members used to create this timber stair construction. So I'm going to label this member because I think it's important. Floor joist. Perfect. Let me just move this across. I think I can even reduce the scale of this. This does not have to be that large. This across over here, and this would be a timber stairs. Now, let us now change this into a three-dimensional drawing. Okay, so before we do that, we are going to switch over to polar tracking, and we're going to observe our 30, 60, 90, and 120 degrees. All right. So all of our measurements are here. Check the line up, and that line going up is going to be 196. 196, and I'm going to turn this on. I thought it was on. I'm going to project this over at 30 degrees, and that 30 degrees distance is 279. Then we go up again, 196. I think I can copy in the recipe. Copy. Yes, I know I can copy array and do that. You know what? Before select that array, and just put in. Looks like a lot of quick moves. I'm going to use the tools that I've shown you all in the past. Now, I'm going to project that all the way here. And now I'll copy this out 150. Yeah, and I'm going to take that, delete that. Then I'm going to create the base here. So 115. And then that goes out to there. And that connects. Copy this down 150. Now, give this a thickness. Good. Close that. Connect these lines here. Copy this one. So this is my concrete stairs. What am I going to do now? Let's label. Down. Down. Yeah. Oops. Perfect. Now I can move this joint down. Oh my God, what is happening? Clean as I would like to be. Now I can move this drawing across and give ourselves some space to breathe. Perfect. Now it's time to create the timber stairs in isometric. So that is the concrete stairs. Let us use the same shell to create timber stairs. Right? So I'm just going to copy this across to here. I'm going to delete the hatch, and now I'm going to add a thickness to this. So this is what is going to be deleted now at this stage, because this needs a thickness, and I'm using a thickness of 2 inches, which is going to come up to 50 mil. So what I'm going to do is I'm going to grab this, yeah, and I'm going to copy it out 50 mil. Go to copy, and I'm going to come here. I'm going to pull that out in that direction, 50 mil. Right. And I'm going to make the connection. Now this is a piece of timber that is shaped like this, and then members are going to be placed on top. So this is the wedge. This is created in the formation of the stairs, and then we are going to lay members on top so that you can stand on top of stairs on the same or the same. Right. So I think I'm going to trim this here. Extend there. Yeah. Yeah, that's good. Perfect. Perfect. Good. Then something strange happens at the top. This is where here you pull this down to here. There you go. What happens? And trim this off. Yep. Then this is copied. Over to here. And then this is done something like this. Comes up here with support. And this comes out here, 50. And then this goes all the way back to yeah. Then I place everything in outline layer. Now I think I can. So now I know where basically everything is. I think I'm going to project this down. It's going to come down 2 or 3. Yeah. Just going to move this. Move that. to there. And then that was there. Yeah. Copy this over. And that will be go 50. And then now we're gonna also send that up in here. So you get 2. And then we're gonna place an X through there. So that lets me know that that is where my floor choice. Right. Cool. So I think I got everything set up. Now, what's the distance that I'm going to be working with? I'm going to use the same distance here. This 2022. That's a nice one here. 2022. What's that distance? Divide that into 3. Probably divide it into 2. Yeah. Yeah. Won't be so fun. Copy. Here. Then we place one. Perfect. You run a line from here. Right through there. And over to here. And a lot of these lines are going to be removed as we develop this drawing because some things are going to be seen and some things are going to be hidden. But right now I'm just setting up the drawing. Then I would then deal with the factors that are hidden and what is seen. So far, this is what we got here. As I'm now going to lay the members on top. Here. So I'm going to lay members on top here. On top, every place where your foot is going to be, are better known as the tread. I'm going to lay some members, some timber members. Okay, so in laying down this member, I realized that you wouldn't see anything in here. Anything in there, nor in here. Hmm. Okay. That's in. That's in. That looks good. Now let's trim. So now from here, I'm going to copy these members up. But I'm not going to copy it all the way because I'm going to still allow you to see the construction that's going on underneath or in the background. So I don't want to hide everything. Just grab this and that. Copy. Don't know what you're doing. This could be rather difficult. So you have to be able to see through the material and visualize this in three-dimensional form, unless it can be extremely stressful and you wouldn't be able to appreciate what goes into this drawing. Okay, I think that, okay, right. Now let's deal with what happens up here. Okay. 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 I'm not talking much now at this stage because I'm trying to focus on everything here. I mean, it's, it's obvious what I'm doing. I'm still here, just concentrating. Right. I think we got it. I think we got it. What I'm going to do is just extend these. Oh, shoot. this. Okay, and then, yeah, bring this down. There's that. That's that. And we check this somewhere on this side. Hmm. All right, perfect. I'll put this into a different layer. Just copy it. Now, now create the copy. Then I'm going to copy this in this layer. So, okay. So, think about the copy. So I'm going to send this from here, here. Just leave it there. That's good enough. Now, what I think I made a terrible mistake. I need to give this a thickness. So I'll copy this and give it a thickness. Thank you for the thickness. I made a terrible mistake. Let's deal with this individually, and then I can deal with it as a group. So let's do this. Everybody, here, here, let's go. So that is supposed to be copied. This is supposed to be moved here. All right, this is one. That's one. Anything else? Right. I think this is the best way I can express this without making it too complicated. I think trim those. Voila. Gone. That's gone. So bit by bit, I think we can see how this is assembled. On this piece here, that we can all see that I'm going to move this here. Okay, cool. This joist also needs to appear another. Wherever this appears, here, but there, move to this, up to extend, extend, raise, and erase. No. Let's remove these at the bottom so you won't see these. The reason why I leave things exposed, let's address that. I leave them exposed so people can look through, feel, and understand the construction process even better. If we hide everything or recover everything, it would be drawn properly, but you wouldn't understand all the details and all the members that go together to make the detail what it is. So that is why I purposely leave things exposed, like around here is exposed, huh? So that they all can understand and make sense from the detail. All right, I think we're coming good so far, so well, so good. Close this here. This. And let's have a chat of what is done so far. So far I've created a concrete stairs, orthographic, timber stairs, orthographic. Then I've created a concrete stairs, isometric, along with the timber stairs, isometric. Now, so I've done that and I've showed the difference between these two stairs. Clearly, we can see how the concrete one is assembled. We're just pouring the concrete, and for the timber one, we have to do slightly more. All right. Now, I'm just going to the aesthetics. All right. That's the aesthetics. So that's looking into two. Now, what I need to do now is answer the second question. So this is one question done here. And this is where we get my marks. Let me label what I've done. This will be called a concrete stair. And I will put here so isometric detail. This will be a timber stair, and this will be isometric detail. So far, so good. So far, all is well. Now, let us move on to this question. Question 3 asks, make a neat, well-proportioned orthographic sketch to show clearly the following parts of a timber straight flight stair. So it is not supposed to be a three-dimensional sketch. So we have done the three-dimensional sketch, and we have also done the orthographic sketch. But what we are going to do is we are going to develop the orthographic sketch so it will have a nail post, baluster, handrail, string, and thread. So we are going to enhance this sketch down here. All right, so let's see. All we need to add to this is a nail post. So I'm going to set my nail post here. Again, this is a sketch. So it doesn't have to be fully accurate. I'm going to use a thickness of 150 for my nail post. You know, I can use 100. No need to do that. And what's the distance that I can send this up? Now I had some distances here. Let me just check. And the distance for this is supposed to be 840 right here. 840. 140. We would use that, but it's taken from this first step here. I'm going to offset 840 up. Okay, let's trim. Okay, great. That's my nail post. What does that mean? I'm going to copy this. Copy. Cool. Now, let's highlight the pitch line. Extend. That's my pitch line there. And now I need to copy that or move that up to where my handrail line would be. And now I'm going to put my handrail here. Again, I am guessing these things because this is a sketch. So, don't ask me what's the distance. I will place the distance at the end. But I'm just letting you know this is a sketch, so it goes easy on yourselves. So trying to get everything done to a specific distance. You're not being marked on your accuracy of distances. You're being marked on your accuracy of knowledge of knowing where things go. All right? And making sure they look beautiful. So, copy. Copy an array. I know that. I showed you guys that. But sometimes I like doing things in a very simple way. Why? Because for educational purposes, not everyone learns things the same way or likes to know quick method. Some people actually like the slow method. Yeah. So I'll put in the new post. I'll put in the balusters. I already have my thread here. And I am going to place, what else do they need now? So I have my new post. I'm going to label my balusters. I'm going to label my handrail, my string, and my thread. And then this would be finished. I'm going to give this a thickness though. Let me give these a thickness. Thickness about 20. And then I'm also going to give the handrail a thickness of the same 22. And I'm also going to give this down there a thickness of, let's see what I can do to make this better. And then trim this now. Okay, perfect. Now, what I need to do is label. This will be called the new post. Newelpost. All right. Call a baluster. Balustar. Check the spelling. Eall. Ealluster. Now, let us go and place the handrail in. Copy this. Handrail. Mm-hmm. To be the string. Third would be here. Let me create a new. That's with thread. Then ask for the razor so I can remove that. I think that's it. We gave them the new, we gave them the baluster, we gave them the handrail, we gave them the thread, and we gave them the string. So once I've done that, my job here is done. My job here is done. Yeah. Let me just bring these closer to the drawing so that they're all related. Yeah. And let me just place my text now into the proper layers. Now, let us review this lesson. We started off this lesson by going through the parts of a stairs. Now, let's start from the beginning. Types of stairs. There are three types: the straight stairs, turning stairs, and continuous stairs. And spinning off of the turning stairs, we have the quarter turn stairs, half turn stairs, and the 3/4 turn stairs. Also spinning off of the continuous stairs into circular, spiral, and helical stairs. Now, we have parts of the stairs. We went through this. We went through parts of the baluster, the handrail, the narrow post, the soffit waist, the nosing, the squasher, the step, the riser, the tread, the going, the pitch, the headroom, the string, the flight, the landing, and the line of nosing. Also, materials in stairs. We can get materials such as steel, concrete, glass, timber, and plastic. All these materials go to make up stairs. So that is what we did at first, and then I came here and I created my concrete stairs. I created an orthographic projection first, and then I created an isometric projection after of a concrete stairs. Then I did the same thing with the timber stairs here, created an orthographic projection, and then I created an isometric projection of the timber stairs. In doing this, I answered 2 CXC questions. CXC questions. These questions were taken from the 2011 and 2014 building drawing paper. These questions were both taken from section 2. First question that I answered required me to create a well-proportioned three-dimensional sketch. Create well-proportioned three-dimensional sketches to show the difference between a reinforced concrete stairs and a timber stairs. Both of these are straight flight stairs, and you're supposed to label the differences clearly. I've done that. I'm going to come back and further label here so that we can see. Second question asks for me to create a well-proportioned orthographic sketch to show clearly the following parts of a timber straight flight stairs: narrow post, balusters, handrail, string, tread. These have all been identified here. Now what I'm going to do, I'm going to come up here and I'm going to label concrete. Here and here. And this here is not concrete. This is timber. Timber frame. Else we will have here, this will be a flat slab. Concrete slab. And this here would be close boards. Right? So these are timber close boards. Timber close boards. Or to highlight the difference, whatever word you all want to use. But this is a finished CXC exam. No, sorry, it's not a finished exam. It's just 2 questions that I pulled out of the CXC paper, which both dealt with stair details. Cool. So this has been it. This is what the term stairs mean and how to create concrete stairs, timber stairs in both isometric and orthographic projections. I hope everyone learned something from this presentation. If you did, please like and share the video. And as usual, please practice. And if you don't understand something, you can stop the video, rewind it, and take things slowly. Before I go, I want to introduce you students and you viewers to an addition to the channel. I have created up to the time building drawing classrooms, and I have also created up to the time geometry classrooms. So what would you see here in the classroom? In the classroom, you're able to look at assignments and the materials that they use for creating the video. All the material and all the information is here in the classroom. Once you have the course, the class code, you have access. The class code will be placed in the description of the video. It's a new addition to up to the time building drawing. Thank you.